This is a standing back tuck, but you might know it as simply a backflip. Here's how physics apply to this skill and others in gymnastics. Newton's first law says that an object in motion will stay in motion until acted upon by an external force. It also says that an object at rest will stay at rest until acted upon by an external force. So, to start a back tuck, or even just get up into the air, the gymnast must push off the ground. This is the external force that will get her moving, but, of course, she needs energy to jump. The energy to do this is obtained by using her leg muscles, which ties into potential and kinetic energy. When her muscles contract before she jumps, they have energy stored in them, which is called potential energy. Right now, her muscles are similar to compressed springs. Then, when her muscles expand to jump, the potential energy is converted to kinetic energy, which is the energy of motion. Newton's second law says that acceleration depends on mass and force. To get enough acceleration to do a back tuck, a gymnast must push off the ground with a force that is greater than her normal force, which is her mass. This gives her the acceleration to perform the trick. This also applies to pretty much any skill in gymnastics that is performed by pushing off the ground, such as leaps, jumps, and other kinds of flips. Newton's third law says that every action has an equal and opposite reaction. When the gymnast pushes down on the floor before she jumps into the air, the floor springs her back up with an equal amount of force, providing the lift she needs to flip all the way around before landing again. This law also applies to all jumps, leaps, and flips. Angular velocity is how fast something is rotating per unit of time. It may be hard to see in this picture, but in a back tuck, the gymnast's arms maximize her angular velocity when she swings them up and over her head as she jumps. This is the moment when her rotation begins. An object's angular velocity increases if there is less distance between its center of mass and the end of its radius. In other words, the less spread out an object's mass is, the faster it rotates. A human's center of mass is their belly button. This means that the smaller a gymnast makes herself, the faster she will flip. This is why a gymnast tucks in a back tuck. Tucking her legs decreases the distance of her radius from her center of mass, thus making her rotate faster and enabling her to flip all the way around before hitting the ground. This concept also explains why flips in a pike, which is the same position as a tuck but with straight legs, or a layout, which is a flat body position, are much more difficult than tucked flips. The gymnast's mass is more spread out, which makes her rotate more slowly. A gymnast's center of gravity, which is also her center of mass, is her belly button. To stay upright, a person's center of gravity must be above their base. On a beam, a gymnast's base is made narrower because the beam is only 4 inches wide and she must stand with one foot in front of the other. This means that it is harder to keep her center of gravity above her base and avoid falling. Also, the lower your center of gravity is, the more stable you are. This is why a gymnast will bend her legs when she lands a jump or other skill. Aside from absorbing shock and preventing injuries, bending her legs lowers her center of gravity and thus makes her more stable with less of a chance of falling.